So let's talk about the protocols. If you go in CoinMarketCap, which is the place where you get all the info, you have Bitcoin, you have Ethereum, repo, this, that, and now you have 1,634. I think this is not the correct figure. If you go on CoinGecko has CoinGecko has 1,899 coins. You say that exchange, so I don't know why they are not updating that platform. A lot of these platforms are blockchain platform for this, blockchain platform for that. And you really want to pay attention to what is going on in the space. If you're talking about the generations of blockchain, the first generation, you have Bitcoin, a platform that enables peer-to-peer transfer. It brought about the internet of value. We can transfer something of value. And then many platforms came about and said, well, we can do this with this. We could do that with that. We have the emergence of Dogecoin, or let's fork the Bitcoin system and create our own cryptocurrency. You have Litecoin. But those were not enough. Ethereum came on the scene, brought the internet of contracts, smart contracts, and decentralized applications. And then we now have the point where we are going to blockchain 3.0. Maybe there will be blockchain 4.0. It's like the web. There will be a point where you just had website, and then for you to search information, you have things like in categories like communication, this, that, until search engine came, and then with time, JavaScript and other language came in. They could program this. Then you have things like Apache and just technical innovations and many other stuff. Those who know about the internet stuff and all that. Where blockchain is blockchain 3.0. 3.0, blockchain 2.0 improved on blockchain 1.0. Now blockchain 3.0 seeks to improve on blockchain 2.0. There are many problems like scalability. There are many issues like security. There are many issues like privacy. There are many issues like sustainability, of which we'll be talking about in the stuff. Now, what are some of the what will blockchain 3.0 look like? Number one is scalability. What does it mean to be scalable? What I see to be scalable is in two aspects. One of them is vertical scalability. Then the other one is horizontal scalability. Let's make it very easy. When you have a system, it should be able to process more transactions. We're talking about throughput. And then it also should have things like network sharding, network effects. So what that means is the more nodes are connected to the system, the more the transaction should be. So, but if you look at many of these blockchain stuffs, even though you are adding more nodes, more people are joining the network, it does not increase the it does not increase the scalability or the throughput. No, it's not supposed to be so. The more nodes are added, the more the faster the transaction, and the lesser it's supposed to be, the lesser the transaction fee. That is how it's supposed to be. It's like you have a city, and then we have, let's say, 10,000 or 10 caps. Now they will be running around, right? Now, if in that same city you now have 100 caps or 100,000, at least there has to be an effect in the price, because you now have more thousand, more people can get access to more thousand, and it should be lower. That is how blockchain systems are supposed to be. Know that. So there has to be the high throughput, and there has to be the network effect. Then the other thing again is sustainability. So sustainability is something you have to really look at, because when you are building systems, the first question you want to ask yourself is this thing sustainable? Because let's say for example, you're planting a seed. For that seed to actually mature to become a tree, there has to be some sustainable means or medium in place. Why? Because humans, there is a possibility of humans coming to trample upon it. Yeah, it's not going to mature. There's a possibility of pests, diseases, water shortage, natural elements threatening the life of that particular crop. So if you want the seed to grow and mature to be a tree, you have to make sure that all those things are actually taken care of. And that is where sustainability comes in. Now, there are two aspects. We have the human factor, and then you also have the treasury, the financial factor. So sustainability is in two aspects. You have the treasury model, and then you have the governance. So what that actually means is, supposing we raise money, like there are many projects that they don't raise money. Yeah, they just come and sell tokens to people, right? If you look at many projects, after we raise the money for the ICO, and that money is finished, how do we get funds to actually continue the project? And then it's something you want to really consider. That is why many of these projects are saying, okay, let's create a system where we have a wallet where certain percent of the transaction fees in the system goes to that treasury, and then they will have its program in the system. Whenever we need money, it could be a system of voting or whatsoever that will cause the release of the funds. Yeah. Because we're not only charity organizations. You may say it's non-profit. Yeah, but it's non-profit. Who's going to fund research? Who's going to fund all this? Even though we're developing open source systems, at least we're charging transaction fees. All these transaction fees are not supposed to go to miners. All of them are not supposed to go to miners. A portion of them are supposed to go for the maintenance of the system. And then governance. How do we prevent things like forks? If you are building a system where a platform like Aion allows forking of the system, yeah, if you come and you can customize the blockchain to suit your industry. That is a very different case. Not come in and say, well, we don't agree with this policy, we are going on our own. No. How do we ensure sustainable governance? Are we to do election? Are we to do this? Are we to do that? You want to consider all those stuffs. And then the other thing again is interoperability. Trust me, you cannot live in a society where you don't communicate with people. Let's say in a community you live, yours is you go to work, you come back, or you go to school, you come back, and there is nothing. You have no interaction with anybody, you have no business with any person. Your life is going to be miserable. Your life is not going to amount to much. So what that means is a blockchain system is not supposed to be in silos. A system is supposed to communicate with another system. If business A is using blockchain X, that business A should be able to communicate with business B that is using blockchain Y. So there has to be a system of communication. You're talking about platforms like, okay, you talk about the internet platforms. You can embed a YouTube video on Twitter or on Facebook or on your website. So until there are systems here that will enable the embedding or the interoperability of platforms, it's not going to be possible. If you watch platforms like Facebook or your email account, there are services that we say, okay, if you want to log in, you can log in. Let me show you something. Let's go to it. I think is it Udemy? Udemy. Okay, log in. So you can see what is there. That is called interoperability. You can log in with your Facebook. They give you that option. You can sign up with your Facebook. You can sign up with your Google account. That is how it's supposed to be. It has to be interoperable with other platforms. And then the blockchain 3.0 is a kind of platforms that has to be asynchronous. Now, if you look at the blockchain systems, most times they tell you, okay, for a transaction to be confirmed, it has to be you have to mine the block, then you have to sync with the system and many other stuff, and all these things take a lot of time. Well, it's a very, very complex system. But until we design systems that, number one, are BBFT, it has to be Byzantine fault tolerant, and then it has to be asynchronous. So you don't have to wait for a transaction to sync with the whole system. No, let's divide the system into different places, and every person can be doing their own thing. Why we can actually mention that the network is good. So the platforms that I believe that are going to win in the future, they are platforms that are asynchronous. That is what I believe. And then the blockchain 3.0 will be platforms that have privacy. Privacy in smart contracts, privacy in transactions. There has to be privacy. Now, when we talk about privacy, there has to be we have to define what privacy is. There are people who want privacy and don't want to be using it. We have concerns like the funding of terrorism. We have concerns like money laundering. We have concerns like illegal trade, maybe slavery or drugs or whatever. So when we define privacy, we have to define what is privacy and what is not privacy. That is, privacy is a very complex issue. So you have to look at all the system. And then the blockchain 3.0 will be platforms that have the ease of use. So by ease of use, I mean, if you look at many of these blockchain projects, their wallet is a mess. The user experience, it's a mess. It's a mess. User interface is a mess. Many of them don't have content management system. So what that means, if you look at a platform like let's say Nuls. Nuls is one of the platforms that are trying to build kernels or modules that will help people develop blockchain platforms or whatsoever. Then another one again, you have a platform like Unibright platform. And then you have Sophia TS. I think many of these platforms are beginning to understand that blockchain is heading to the point where, just like the internet, you have content management system like WordPress, like Blogger, like Wiz. You have to develop content management system. So you have to develop all these stuff. So the ease of use, it has to be there. Then the other thing again is there has to be digital asset management. Where blockchain is going now, whether you're developing protocols, smart contract, or whatsoever, you have to think about how do we manage digital assets? How do we prevent things like copyright? How do we ensure privacy? How do we ensure that the people who are the authors or publishers of these assets or owners of these assets have real value for what they have? And how do we digitize all the world assets? That is where the blockchain 3.0 is going. So it's a very huge industry, but it also has its own challenges. So if you want to tokenize all the real estate in the US, for example, what blockchain do you need? Those are many questions that has to be. And that thing again has to be consensus mechanisms. Bitcoin, for example, it's one of the proof of work is one of the most proven blockchain consensus algorithm that we know for 100% certainty has not been breached so far. When we're talking about proof of stake, there are many problems that proof of stake have, things like nothing at stake problem and all that. But this Bitcoin proof of work, it has drawbacks. Even though we know it's very efficient, but it's slow. It's time consuming. It's not environmental friendly and all that. So we want to seek ways around this to solve all these problems. And then the ninth thing that you have to consider is the issue of computation. I truly believe that one single blockchain cannot handle everything. There has to be layers of off-chain computation. That is one of the things I believe. And one of the platforms that is doing that, there are many platforms. You have, depending on which one you look, you have Golem. Golem is trying to do something that is relating to a form of computation. You have am I getting it right? Sun or Snom. You have ISEC, RLC, ISEC, and many other platforms. So the issue of computation has to be solved with blockchain. Then the last thing but can really touch about is data storage. So blockchain has not really figured out a way where we can actually store data. We've not figured out a way where we can actually store data. We're talking about, to go back to computation. Many of these platforms are still deployed on centralized systems like Amazon Web Service or whatsoever, or Google Cloud or whatsoever service, or Microsoft Azure. We have to create our own systems for computation. So blockchain have not really figured out a way to solve the data storage problem. Many of these data, a large percent of this data is transactions that actually happen. If you look at it, it does not really have real use case. Like the Bitcoin network, we're talking about lots of gigabytes of data, and these data are just transactions. You may say, well, the ledger is there, anybody can go and say, but if this is a pen and I've used the pen, they've already certified and all that, at least blockchain systems are supposed to be systems that we have to define what is to be stored on the ledger. So when we are building the blockchain systems, we have to define how long transactions are going to stay on the blockchain and what kind of transactions are going to stay. If you are putting property rights, or you are putting real estate or token or tokenization of assets and all that, they can stay. But if we are talking about transactions like buying of this, you know that you want to keep them there, it looks somehow. Or we have to blockchain have to figure out a way where maybe there have to be a research in among blockchain platforms on how do we ensure data compression, or how do we these data are not there, but we can still prove, just like zero knowledge proof, that you're not revealing everything to the person. A platform, you're not revealing everything to the person, but you can still prove that the person actually sent the money or the token. So there have to be research in systems here, like further data compression. So let's say a platform of 1 megabyte comes on the blockchain. How do we prove in such a way that we can save a copy of it that is, let's say, maybe 10 kilobytes? That is one of the things that we should actually consider. So these are the 10 steps: scalability, sustainability, interoperability, talking about asynchronous and it has to be Byzantine fault tolerant systems. Then privacy, the ease of use, digital asset management, consensus mechanisms, computation, and then data storage. So guys, thank you very much for watching. Bye.